So hi everyone, and thanks very much for having me. So I'm very happy to be here. So I was kind of completely dislocated from the sort of sonification world until pretty recently, but it's something that I've been thinking about actually for quite a while. So I'm an astronomer. I work as a fellow at the Institute of Cosmology and Gravitation in Portsmouth. And a lot of you might know that the ICG hosts the Tactile Universe project. So it's got a good track record of doing accessible astronomy. And one of the things that I really wanted to get started while I was doing here was to collect sort of a lot of these ideas I'd had around sonification, or just playing with audio and data together and sort of codify it and make it into a code. So that code so far is called S.T.R.A.U.S.S, which of course stands for a suite of tools and resources for astronomers utilizing sonification for simulations. And yeah, it's quite a narrow remit to begin with, but the general idea is that this code should be used, or can be used, to kind of simplify this sonification process from going from data to something that sounds good. And there's kind of and there's a general kind of musical approach to this. So yeah, trying to focus on making sonification that represents the data in a way that sounds good or is captivating or interesting to listen to. So it's a big ask, but one of the things that I wanted to start with was just the general motivation behind this. And I'm sure a lot of you will be on board with this already, but so generally sonification, so I see sonification as a kind of key component of accessible science. Clearly, astronomy is very visual, or it has been for since its inception. But just like we visualize things, we can also transfer and translate data into sound. Sonification also, of course, has unique benefits over visualization. So given that the frequency range of the human ear, for example, is like 3 dx versus 0.3 dx for the eye. The particular application of simulations here is useful because simulations, as opposed to static, provide a dynamic picture of the universe, which I guess in many ways is more conducive to sonification, because it's things happening over time, just like audio. And finally, that as well as being engaging and clear, this sonification should be enjoyable to listen to. There's some sort of aesthetic sense we need to develop for sonification. So generally, so this code, the general structure is that you have some data, you basically map that data onto objects called sources. So these will be the things that emit sound. You follow some sort of score, so some way in which you're going to make sound, whether that be chords. I'll talk about that later. Then there's a generator which makes the sound essentially, and finally a kind of audio mapping that maps these into sort of stereo channels. And in particular, the spatialization is something that I'm interested in doing. So using stereo and panning and all these kind of things. So what I mean by sources could be in the code. These are just a kind of abstract thing, but this could either be events or objects. So, for example, they could be supernovae going off. That would be an event. It could be an object like a galaxy. And that event or object has some properties that we can map to audio properties, like, say, the position in the sky can be mapped to the sort of the spatialization. The volume can be mapped to sort of how far away something is or how intrinsically bright something is. The pitch can be mapped to things like secondary characteristics like the color, timbre, all these different things. So we basically have some fundamental mapping of sources, and they're mapping their properties to audio properties. The next stage is then to give these sources to kind of dictate what these sources play. So the general idea of this is having some sort of score. So you have a timeline over which events happen or objects evolve. So in a simulation, you could have supernovae going off, or galaxies spinning around, or you're flying past a galaxy. These are things that are happening over time. And then over that timeline as well, you can have some sort of score that dictates the sound you make. So this could be free form, where you're kind of fully dictated by the data. So a pitch could be any possible pitch over some range, and if something goes high, something goes low, and you're not thinking at all about sort of how it sounds or you're just purely dictated by the data. The opposite extreme is like a full score, where you take something like a piece of music that has completely prescriptive notes and lengths and things, which is you can also modulate by the data in various ways, but it's much more subtle, and you're kind of mixing up things like rhythm in the piece with rhythm, like things that are happening in the data. So that gets confusing. And the main sort of approach that I've been trying so far is this kind of chordal approach, where, so in a musical sense, you have some kind of chord progression, and you can use events or sources to play the notes in this chord, essentially. So now you've got the sources and you know what they're supposed to play. You can either generate sound using a sampler, so you can sample audio. So this could be notes on a key, on a piano, or a glockenspiel or something like this. Or you could synthesize them, so just generating them mathematically. And I've tried both of these approaches, but so either of these, it can work, and they have their own sort of advantages and disadvantages. But I wanted kind of the functionality of both to be there. And then once you generate that sound, you can mix that into audio channels. And one of the, as well as stereo, it's set up so far that you can export it in things like 5.1 and 7.1 and all these kind of surround sound setups, so that you can play this in sort of planetaria and things like that. And so the idea is that we could have sort of a standard setup templates for all these things, and you could get in as much detail as you want, but that it should be generally easy to take some data set and sonify it by just making the decision of how you're mapping certain properties to sources and properties of those sources to sound. So that's the general idea. I don't know if I actually shared my audio when I started this, so I might just unshare and share again just to double check. So some examples that from what we've done already. Can you hear this? People hear things?
Yeah.
So I don't know if it's in stereo.
It is.
Okay. So what you're hearing. So I'll pause it for a second. So what you're hearing there is black hole events. So this is black hole mergers. So our sources are black holes in a simulation. So this is a cosmological simulation of the universe, and you're hearing black hole mergers. And this is kind of abstractly mapped to drum samples, and how loud they are is dependent on how far away they are from you. You're sat in the middle of this cosmological simulation, and how loud they are it depends on how far away they are, and their spatial mapping depends on where they're happening all around you. And the mass merger here is mapped onto different drums. So you're hearing different drums that one will represent one mass ratio and one will represent another. So just an example of how you can do this. So these are black hole mergers happening, and rather than say the pure waveform that we're familiar with, this chirp that you might have heard from the LIGO detection, this is mapped onto drum sounds. So this would be an example of an event sonification, what we call an event sonification. Another example, a musical example, would be this one, where now you're flying through the simulation and you're hearing galaxies, and galaxies, depending on their mass, are playing different notes of a chord. So like the most massive galaxies will be the bass, and the lower mass galaxies are the sopranos and altos, for example. And here they're just playing out a chord. So you're flying towards a massive galaxy past other galaxies. So you can see how this syncs up with the visual. And again, so that was just a single chord, and you can also have the chords change. So that was the other aspect of this score. We can have a sort of musical chord progression that changes as you evolve. So the same video where you have a chord change going on would be this, for example. Yeah, so yeah, okay, so that was basically a general overview of the sort of stuff I've been working on. So I just wanted to sort of demonstrate what I've done so far. A lot of this is kind of stuff that we need to work on in the future, you know, in lieu of funding and all this kind of thing. We've got a small grant in for some money to just for some equipment, basically, to help develop some of these aspects, in particular with connection to VR, which I haven't had a chance to talk about in detail here. But yeah, hopefully within the next year or so, I'll have a code that people will be able to take and use for themselves to generate these kind of things.